Welcome back to the Programming with C++ course. We're learning C++ as per ISO ANSI standards. The course is given to you by Subaraj Academy. And you are at lesson 3A, operators. I'm sure by now you have your IDE is ready. For the IDE, Integrated Development Environment. And you are able to write the source code, the program, and able to compile it to get the object code, and able to build the program and run it. You follow the steps: source code, object code, running. Executable code. That's called executable code. So I hope you will experience. If you have difficulties, you talk to your seniors or your system administrator. They'll help you to find a good IDE. Okay, all IDEs are good, but I use code blocks. Sometimes I use the Microsoft Visual C++ also, or Visual Studio. So it's a must for you to understand this course. And I've also given a name of a book which I'm following. You can also buy the book, it's not very expensive. And you can follow my lecture better by reading the book side by side. Okay. Now, when we're discussing about types of operators, in all there are 4 types of operators. We'll look at them, each one of them right now. The arithmetic operators, you know it, plus, minus, multiplication, division, and modulus. Relational operators, logical operators, and bitwise operators. I'll discuss in detail. So the operators, when the operator, suppose A is 4 plus 5, the operator is plus. The operators are 4 and 5. In this case, it involves 2 operands. 4 plus 5, 2 operands. So it's involving 2 operands, so it's called binary operands. If it involves single operand, then it's called unary. In fact, the operator is also called unary operator. The plus is the binary operator. Okay. We'll see plus, that will be unary operator. And there are ternary operators. It involves 3 operators. We'll see all of them in this lesson. So, I told you about 5 basic arithmetic operators supported in C++, standard C++. Addition, C is equal to A plus B. 8, C is equal to 8 plus 5. Subtraction, C is equal to 8 minus 5. Multiplication, C is equal to 8 into 5, into is star. Division, C is equal to 8 by 5. What will the answer? You will get only 1. If it's the floating point, if you do, then it may be different. But here, if 2 integers divide one integer by another integer, you get only the quotient. Modulus, you will get the remainder. So when they say 8 modulus 5, you will get 3. 8 by 5 is, the remainder is 3. Here 8 by 5 is 1. So when you do the division, the quotient you will get 1. And the modulus will get 3 when you take 8 and 5. So these are the 5 basic operators. You are very familiar with all these operators. Right? You can have expressions. Expressions are nothing but combining data types and operators. The type can be a variable or a constant. Operator can be any of the 4 types of operators. Okay, that's why you have expressions. You have operators and you have expressions coming out of the operators. So the operators have a precedence rules. In a complex expression, let us take the example itself. See, look at this example, 24 by 6 into 4. So the answer is 24 by 6, 4. 4 into 4 is 416. Suppose I multiply the 6 into 4, 24. 24 by 24 is 1. with the right answer. And then look at the next one, is much more complicated. 24 by 2 minus 8 divided by 4 plus 3. Will they add this first? No. So there is an operator precedence. There is an operator precedence in mathematics also. So there is operator precedence for each language. In C++ also there is each. In fact, the divide and multiplication have higher priority. But when they appear together in an expression, you go from that. I will show you that. See, star, divide, modulus, they are the same precedence. But you go from, if they appear in the same expression, you go left to right. Plus or minus, they have lower precedence. So look at this. So we have star as well as divide. So they have the same precedence. So you have to go by left to right. 24 by 6 is 4. Into 4 is 16. Similarly here, divide has the highest precedence. But you have to go by from left to right. 24 by 2 is 12. The next of the expression is there. Then 8 by 4 is there. 12 minus 2. 10 by 4 is 2. 10 plus 3, 13. So that's how the operators are evaluated. So operator evaluation is as per the operator precedence of the language. So look at, you can Google it, find out the operator precedence rules for C++, you'll get it. And the results are here. First calculation you get 16 and second calculation you get 13. Okay, that's our operator precedence. Operators and operator precedence. That comes for. Now I'm going to introduce to you. We looked at arithmetic operators. Now I'm going to introduce to you arithmetic assignment operators. What are they? Generally you write A is equal to B plus C. Suppose you may also write A is equal to A plus C. Expression 1 is equal to expression 1 plus expression 2. When you get that kind of expressions, then you can write in a simple form. This can be written as expression 1 plus equal to expression 2. So when the right hand side involves the left hand side expression, then you can write simply as expression 1 plus equal to expression. This is called arithmetic assignment operators. So normally A is equal to A plus 1. This you can write as A plus equal to 1. The shorthand form or arithmetic assignment operator. A is equal to A minus B. So you can write A minus is equal to B. Okay, see, because the A is there on the right hand side, which is also the left hand side. So in which case you can write it in a shorthand form. A star B plus B, you have to write it's A is equal to A star is equal to B plus C. A star is equal to B plus C. A is equal to A by B, A slash is equal to B. D is equal to D minus A plus B. So D is equal to D minus is equal to A plus B. X is equal to X percentage Y. So X percentage is equal to Y. So this way you can write the expressions in a shorthand form. So that's called arithmetic assignment operators. There are unary operators derived from this. The special operators for a single operand are called unary operators. These operators can be used for adding one with incrementing to an integer variable or subtracting one, decrementing from the integer variable. So like x plus plus. X is 5, x plus 1 will be 6. And x minus minus will be 4. The decrement operator plus plus and decrement operator minus minus are unary operators. So using unary operators, let's write a program. So include IO stream, which is the standard library, which is useful for input output through keyboard and monitor, standard input output devices. So I first I had to include this, otherwise the program will not work. I'm saying I'm declaring var1 as an integer and also assigning number 9 to it. So you can do this. So integer variable 1 is equal to 9. Then comma var2. I'm combining declaration of two variables. So var2 is also integer. See? Look at the previous program, how did we do? Here we didn't declare anything. So in this program we are declaring an integer where 1 and where 2. But where 1 I am assigning 9 and where 2 I am not assigning anything. So it will be assigned to 0. The integer not automatically the default is 0. And then write where 2 is equal to plus plus where 1. What is where 1? Where 1 is 9. What is plus plus where 1? It will be 10. So where 2 will be 10. See the printout, I am not using namespace std here. Then I don't have to put, if I put using namespace std, then I don't have to put std prefix here. Since I have not done that, I have to put a std prefix here. Std prefix cout. This is a new line character. So jump to the next line. Where 2 will be? What is where 2? Where 2 will be 9 plus 1, 10. And you go next step. What is where 1? Where 1 is 9. Where 1 is 9. Oh no, where 1 will be plus plus. We increment. Where 1 was 9, we increment it to 10. See, plus plus where 1 becomes 10. So where 2 is 10 and where 1 is also 10. See, this is the result. Both where 1 and where 2 and where 1 are 10. Now I'm saying where 2 is equal to where 1 minus minus. So I print where 2 and where 1. Where 2 is equal to, what happens is, before decrementing, where 1 will be printed. What is where 1? Where 1 was already 10. So 10 will be printed. Then 10 will be decremented and you will get 9. It's a little complicated. Look at this. So the prefix and postfix. When I put a prefix, first where 1 will be incremented. That's why 9 plus 1 is 10 you got. See, where 2 you got 10 because, and where 1 also was 10 because, is a prefix operator. Plus plus 0. See the minor difference. But here it is postfix. I am not putting minus minus where 1. In which case the result will be different. I'll discuss that also. So where 1 minus minus. So what happens? Where 1 was initially 10, so where 2 become 10. And where 1 minus 1 is 9. So where 1 will be 9. Suppose I put minus minus where 1. So I put prefix minus minus where 1. First of all, where 1 would have been decremented from 10 to 9. So you would have got both 9. You got the point? So prefix and suffix also matters when we are using the unary operators, which are used for incrementing and decrementing. So we saw the arithmetic operators, arithmetic assignment operators. Okay. Now we will look at relational operators. So relational operators are very useful for checking relationship between two variables or two constants. And they check relationship between two numeric operators or expressions. Suppose you say simple greater than, suppose write x greater than y means it will check whether x is greater than y. And if so, it will true. If not, then it will get false. Similarly, less than, x less than y means it's x less than y. You can combine equal to also with this, greater than or equal to. You understand this. I don't know to explain this. This is very fundamental mathematics. X greater than equal to y. So you write this way. Greater than equal to. This means is greater than is x greater than equal to y. And similarly x less than equal to y. Okay. Then equal to two equal to signs. See, when you put single equal sign, it assigns x equal to y means y will be assigned to x. I repeat, if I say x equal to y, then y will be assigned to x. But when say equal to, you check the equality between the both sides of operands. Okay, equal to x equal to means it will check whether the x is equal to y. If so, true. If not, false. Not equal to, this is written like this exclamatory mark, then equal. If x not equal to y, suppose x is 5, y is 6, x is not equal to y, so the result will be true. Okay, and when they are same, when they are equal, the result will be false. So these six expressions, six operators are used for checking relationship from left hand side to right hand side. The outcome of relation expression is either true or false. True also is indicated by 1, numeric 1. False is also equal to 0, right? And I also told you, I have not told you that. Any non-zero integer will be identified as true, and 0 will be identified as 0. 0 will be identified as false. Any non-zero integer will be identified as 1, and 0 will be identified as false. So assignment operators are written as identifiable expression. Suppose we want to say y is equal to 5, we write y equal to 5. Okay, that's assignment. Okay, that is assignment operator. But y equal to 5 means it is kind of checking a relationship whether y is equal to 5. See the difference? Double equal to means you check the equality. The single equal means assignment. Let us write a program to demonstrate relational operators. I declare var1 as integer and assign the value of 5. And I declare two Boolean variables, b1 and b2. And to b1, I'm assigning the result of var1 greater than 3. var1 greater than 3 is a relational operator greater than. So what is the result? var1 is what? 5. And is it 5 greater than 3? Yes. So b1 will be true. And the steady C out, new line character, expression 1 is b1. It will be true. So it will print 1. The true and 1 are same. Similarly, b2 is equal to greater than 5? No. See, var1 is 5. 5 is not greater than 5. False. So when you print the expression to b2, it will be 0. This is the result of the expression. So you can check like this. It's the greater than expression, greater than, and greater than only we are checking this. We can use all operators. As we go along, we'll use all operators. Now I'm giving you a simple introduction. But all these operators will be used at the rest of the course. So what are we, let us recall, we have looked at arithmetic operations. They are arithmetic assignment operators. Then we looked at relational operators. Now we look at logical operators, third type. So and it represents two ampersands. And is represented by two ampersands. R represented by two, this is two straight lines. No? When you use shift, we can easily type it, the vertical line. Okay. In the keyboard you'll find the, you can easily find out. Yeah, the line is there. So R means two vertical lines. Not means exclamatory mark. So these are the only three logical operators. Okay. And R not. Okay. So I'll give a simple example. Suppose x is equal to 5. Okay. I have to give an expression to you. So two expressions. If they are connected with and, so both should be true. If x is true and y is true, x and true is true. If x is true and y is false, x and true is false. Whereas r, x, r, y, if x is one of the truths, the truth table. If you look at x and y have a truth table, the x and y will be equal to 1 only when both x and y are true. Whereas r, any one other one is true, the output will be 1. R will be false only when both x and y are false. Not in negation. If x is equal to 1, y is equal to, x bar is equal to, x naught will be 0. And if x is equal to 0, x naught will be 1. So these are the logical operators. We also use typecasting. Typecasting means you can convert from one type to another type. For examples, into x, you declare x as integer, and float y is equal to 2.5. So you can combine like this, declaration and assignment. X is equal to integer y plus 5. What is y should be typecast to integer. Y is what? 2.5. So what will be this one? Integer? It will be, we have to check whether it's 2, whether it's 3. It will be 2. 2 plus 5, 7. And result is float 5 by 2. 5 by 2 will be 2. Into 2 will be 4. Okay, this will be, we are typecasting this expression to float. 5 by 2 is, sorry, 5 by 2 is 2.5 because the, no, inside, no? Inside, here, this is a very tricky problem here. Since the cost operator has lower precedence, so the casting will come later. So 5 by 2, you will get only 2, because 2 integers. And 2 into is 4. And when you come to float, you will get 4.0. Since cost operator has a lower precedence, the expression within parentheses will be evaluated first. Okay, here again, the int will be, int is lower precedence. So what is y? Of course, here it doesn't arise. 2.5. The y is 2. 2 plus 5 is 7. So we looked at logical operators, and the last type of operators, bitwise operators. So there is a difference between logical operators and bitwise operators. Logical operators, they were checking two operators, two expressions. Whereas bitwise operators access the internal representation of the numbers, number of numbers in the bits. Bitwise operators for, it looks at internal representation of numbers. But logical operators, they don't check out, they don't look at the internal representation. They look at only the external representation. 5 and 4. No, not 5 and 4. So if x1, x and y means if both are true. So the whole x is taken. But whereas the bitwise operators, they look at the internal representation of bits, then they only ones and zeros. These operators apply only to the integer family operators, including char. So you can use the character or integers and use the bitwise operators. The fourth type of operators we are seeing in this lesson. So here, so when the logical operators, we had two ampersands for and two lines for or. But whereas in the bitwise operators, you will have single ampersand for bitwise and one line for bitwise or, and the exclusive or is there. Suppose a is equal to 1 and b is equal to 1, the outcome will be 0. If both are 1, outcome will be 0. If both are 0, also outcome will be 0. If only one of them is 1, the output will be 1. That's exclusive or. And left shift, you can shift it to the left and shift it to the right, right shift, two arrow pointers. And bitwise, unary not. So it gives, suppose the 1010 is the number, you will get 0101. So 2, 4, 6, there are 6 bitwise operators. I'm going to give an example. So actually, we take the 8 bits. Each integer has 8 bits we're taking. Okay, let's say here. So we want to demonstrate bitwise operations. Int C, A is this, and B is equal to 0. So 6 means 1010, 1010, like that. No? Single, if I assume a byte for each character, like ASCII character, no? 1010, like that. There will be 12 characters. Repetition of 1010 3 times. And B is equal to 0, 12 characters of zeros. When you add both, since B is 0 always, all the 12 characters, the result of A and B will be 0. That's the result of A and B will be A and B will be 0. The result of AND will be 0. Got it? See, 6 is 1010, 1010. And B is all zeros. So when you AND the 0 on any number, it is 0. So when you do OR, you get the number itself. All 6 will get. So A or B means OR will be what? A itself. What is A? 4 sixes. Got it? Because OR means 1010, bottom is 0, but so 1010 will get. So the result of OR will be same as A. And C is A exclusive or B. So You see A exclusive or B. So A exclusive or B, and B is 0 always. So you will get only, this expression will turn out to be 1 only when A is 1. So 1 0 1 0, 0 0 no problem. So 1 and 0 will be 1. 0 0 exclusive R will be 0. Understood? See 1 0, let's take only 4 bits. A is equal to 1 0 1 0. B is equal to all zeros. So 1 and 0 will be 1. 1 exclusive R of 0 is 1. 0 exclusive R 0 is 0. 1 exclusive R 0 is 1. And 0 exclusive R is 0. So you get 1 0 0. So you get the same A itself. So exclusive R of A, you get all 4 6. Now, not A. When you say not A, you are going to have a negative number. So the result of not A will be 6668. So it is a minus 66667. So that is negative number is in two's complement rotation. It will be two's complement rotation. So you can convert it into normal number. So all 4 6 will get you two's complement minus 6667. So I explained you the operation of matrix operators. You can also take more examples and see and clearly understand. In the book I have given all examples. Okay. Optical programming with ANSYS, standard C++, published by Vikas Publishers. I have given you a number of examples. You can look at it. So I would suggest you read it and buy it. It's not very expensive at all. So in this chapter on operators, we looked at 4 types of operators: arithmetic operators, then relational operators, logical operators, and bitwise operators. I hope you understood the whole thing. Good. That's all for now. Until we meet again. Bye bye.